Alright, so we're talking in this section today about 4.6 and, 6.7. Well, I am making too many videos right now. 6.7, and so if you look at the warm-up for 6.7, we've got a circle centered at the origin, and we need to find a point that's on the circle in each quadrant. So, we're trying to figure out two numbers that when you square them and add them together, you get 25. So, one thing to keep in mind is what the radius of their circle is. The radius of this circle for problem number 1 is 5. And so, how does that help us? I'm not really sure. The radius for problem number 2, that's 2. Not extremely helpful. If I could come up with the right numbers that add up to 25, that'd be helpful. Like, I don't know, I could use 1 and 24, but then I need the square root of 24 and the square root of 1. The square root of 1 happening to be 1. So I could pick that as one of my numbers. That one's not very interesting, but we could use that. Probably a slightly more interesting way to do this one would be to think about some of the triangles we learned before, particularly the 3, 4, 5 triangle, where 3 squared plus 4 squared, or 9 plus 16 is 25 squared. So then we can use 3, 4 in quadrant number 1. If I wanted to go to quadrant number 2, x is negative, but y is positive, and so I just change it. It's a pretty straightforward switch. And so 3, 4, 5, for a radius of 5, that one's fairly simple, because we have a triple that goes with it. But for the second one, where our radius is 2, still centered at the origin, a circle, we're looking for points. This is a little bit harder to pull off. And so trying to think about what that might be. Some of those things that we did where we were trying to find the points with the degrees, we could use that if we really wanted to. I'm not that fancy. So I know that 1 plus 3 is 4. So if I took the square root of both of those numbers, and so 1 and the square root of 3, and then 4 would be, and then 2 would be my numbers that get squared to make a sum. So I can use 1 and the square root of 3, or the square root of 3, 1 to be in the first quadrant. And then if I wanted to move into the second quadrant, x needs to be negative and y needs to be positive. In the third quadrant, they're both negative, and in the fourth quadrant, x is positive and y is negative. So that's the idea with this warm-up. It's fairly straightforward. See what you can do about some thoughts for some of the other places. And let's move on to the task. After considering different plans for laying out the archaeological site described in 6.6, digging it, Alice, Javier, and Veronica have decided to make concentric circles at 10-meter intervals from the central tower. They've also decided to use 16 stakes per circle, because 12 just wasn't enough, to have a few more points of reference. Using ropes of different lengths to keep the radius constant, they have traced out these circles in the sand because they know the circles will soon be worn away by the wind and people's footprints. They feel a sense of urgency to locate the positions of the 16 stakes that will mark each circle. So they've decided, you got your central tower, and they've decided to make circles of did I not pull it up? Circles of equal radii. I don't know why that's not working. There it is. And so there's our center. And so they're using 10-meter intervals. So there's one, and they're going out 10 meters from that, making another one, then 10 meters away from that, making another one, and they've already drawn all these circles. But they're worried that, because they've just traced them in the sand with a stick, that what's going to happen is the wind's going to come and everything's going to blow away. So they're really concerned about getting all the stakes placed, and they don't want to make measurements over and over again because it takes too long. So they're looking for an efficient way to get it done. So what we're actually creating here right now is something called polar coordinates. And they're a little weird, but basically it's a way to measure something using S, and S being an arc length, and R, or the angle and the radius. Because if we know the angle and the radius, that would be, that's easy to find. And so it'd be great. And so we're hoping to kind of play games with that a little bit more. So Veronica, part 1 is what we're going to be working on today. Veronica suggests that they should locate the stakes around one circle and use these positions to mark where the stakes go on other circles. And how is this helpful? So if you recall from task 6.6, once we knew where they were on the one circle, we were able to kind of figure out what was going to happen in the other circle because it was following the same pattern. We were taking half of the radius and either timesing by the square root of 3 or the square root of 3. Is that there's just a clear relationship between the 2 points as we move out. So if we can figure out one circle, we can just kind of extrapolate that to all the circles. It's not going to make very much difference. And so that's Alice's idea, is that we'd be able, Veronica's idea is that we'll be able to do that. And so what you needed to come up with here is why it's helpful. If we find them on one circle, how that will help us with all the rest. Which is a pretty interesting idea. So Veronica's decided they should stake out the circle with a radius of 50 meters first. She's standing at the point 50, 0, and she knows she needs to move 22.5 degrees around the circle to place her next stake. But she wonders how far is that. So 22.5 came from 360 divided by the 16 marks they're making. So she's setting up a proportion using degree measurements. Alice thinks she should do it by taking 1/16 of the circumference, and Javier thinks they should use radian measurements because if you recall again from the task the other day, the radian measures, or the ratio of arc length to radius, came out to be the same no matter what the radius of the circle was. So, they think that would be a helpful thing. So you've got these 3 people's ideas. So what I want you to do is pause and see if you can figure out the distance that all of them are, what they're all going to do here. And that is really your task for the whole period, is to kind of come up with, how do we do this? How do we do what Veronica says? How do we do what Alice says? And how do we do what Javier says? So go ahead and pause. You're going to be away for a while trying to figure it out, and I'll come back with some, not the answers, but maybe the equations to help you do each person's method. Right, so Veronica said she's going to set up a proportion, so here's Veronica's proportion. You'll still need to find out what x is. Alice said they should take 1/16 of the circumference. So there's my circumference, and there's my 1/16. The reason, of course, it's 1/16 is because it's cut into 16 pieces. Javier says they think they should use radian measurements, so I've just converted 22.5 degrees into radians as 0.8. I'm not quite sure what to multiply it by, so keep thinking about that. We know all the answers are going to be the same. So once you have an answer for Veronica's method or Alice's method, see what you can do to find out what Javier needs to multiply by to get Javier's method. Okay? And then, that was an X. I didn't mean to lower that. I meant to do this. So then your homework tonight is to label each part of this, finish labeling this circle in radians. So you've got the example that they asked you to finish it. So they've got pi fourths, pi halves, which is 2/4, pi halves, and then 3/4, 3 pi fourths, and then 4 pi fourths or pi, and then 5 pi fourths, and I just want you to label these last 2. So notice 1, 2, 3, 4, 5, counting, but with fourths. So what are the last ones? Continue counting, simplify when possible, as they simplified B and D. So you may need to simplify a couple of those. And then continuing the same idea. So what would we do here with A, since we cut this into, if you notice with this one, it's cut into 8 pieces, but it's 2 pi cut into 8s, which is 2 pi divided by, so it's really fourths. It's because the pie, the top half, is 4 pieces. So the top half here is 6 pieces, so this is pi 6. So A is pi over 6. And the question is, can you get the rest? And this one, they've cut it into 3 pieces on the top, so A on this one is pi thirds. So keep that in mind and see if you can finish those. That's your hints for the homework. And there's no hints for the other ones. You need to figure those out yourself. Okay, and good luck. We'll talk on the next video.